Hi, this is Jason with Net.Academy. Thanks for joining us today on our AWS journey as we go through networking in AWS. Again, most of these concepts also apply to other cloud providers like Google or Microsoft Azure, etc. But they're very focused on the network engineer, which all of our material really is, right? Today, we're going to be talking about security, particularly network security. With that said, let's take care of the housekeeping items. If you're enjoying the content, please consider giving us a thumbs up and a subscription. And likewise, if you have any feedback, please feel free to leave a comment. This is all about building community. So let us know what works and what doesn't, right? You can also email me. My email's all over the place on the different videos that we have. Usually every first video on any series will have it, but I have it in multiple areas. So let's dive right in. So in any cloud, doesn't matter if it's AWS or anyone else, security is always a shared responsibility between yourself and the cloud provider. It's important that you understand that divide. What is the cloud provider taking on from security? And what is your responsibility? You need to understand what things are your responsibility or you can't secure them, right? So that's number one. Number two, remember, security is one of, if not the top concern for just about every company these days, right? If it isn't, then they're not really reading the headlines, okay? It's job one for all of us. When it comes to security in a VPC, and we're going to limit this to the VPC, we really have two main resources we're looking at. We're looking at network access control lists, or NACLs, and we're looking at security groups, or SGs. Okay, we're going to go through both. One thing is, be aware, we're just talking in this talk about security at that VPC layer. Security needs to permeate everything you do in the cloud, right? From how you create and utilize accounts to the storage you provision, the compute you spin up, the databases you configure, the authentication you provide, the logs that are gathered, and everything else, right? You really need a holistic cloud security approach, particularly if you're going big on cloud. Now, if you're just kicking the tires and trying a few things, I might be overstating a little bit. I might not. Depends on your industry, your company, your needs. But I could appreciate that if you're just trying a few things out, you don't need to go hire a bunch of people to do cloud security. But if you're going to get serious about being in the cloud, I think you really want some dedicated people who understand all those cloud basics so that they can apply them cohesively across your entire infrastructure. Let's dive in. So the first object is NACLs, or Network Access Control Lists. These operate at the subnet level. Hence, that means it's attached to a subnet. It's confined to a single AZ. That means it's not very granular. It applies to every object within that subnet. I don't have any ability to say this, not that, because it's applied as traffic comes into and or leaves the subnet. Okay. They also have a challenge because they are not stateful. So everything you permit in one direction, you probably need to permit in the other direction. So your return traffic can get back, right? They do have a concept of rule numbers and they are executed sequentially. So I'd recommend putting frequently hit objects near the top. Likewise, when you're numbering your NACLs, I would not make them perfectly sequential. I would not go 1, 2, 3, 4, 5, 6. I would go 5, 10, 15, 20, 25, 30, right? Or something along those lines. That allows me to dynamically enter objects as my security requirements change in between two rules, right? I'd also never start at 1 because I can't have a number lower than 1, right? Just as with an ACL on a router or a switch, there's always an implicit deny at the bottom of the NACL. Okay, so the following criteria are needed to kind of create your NACLs. You need that rule number. You need to know what the traffic is, things like port protocol, or port range, things like that. The source IP, and whether you would like to allow it or deny it. Okay. Just remember that they do trigger sequentially. And if I recall, you have to go through the entire NACL before you finish. So you don't want a NACL that's 1,000 lines long. Okay. You need to think a little bit about how you're applying these. Now, what's my recommendation here? Well, because NACLs are not stateful and they're only attached at the subnet level, they don't get granular enough. I find a lot of places don't utilize NACLs. Now, there could be a specific use case and reason. If you're a traditional network engineer, I would say if you have a VLAN that you apply ACLs to on the SVI of a VLAN, for example, you might want to consider bringing that up to the NACL level, right? At least consider it, have the discussion, right? Maybe it makes sense, maybe it doesn't. You're going to see security groups and you might feel that the NACLs aren't as required. The other two areas I sometimes see NACLs is if you're in an IoT shop and they have particular subnets that are built around things like manufacturing or IoT devices or something like that. Or I sometimes see NACLs applied at public subnets so that you limit what is coming in and going out. Let's move on. Okay, security groups. These I see not only all the time, they're actually mandatory. You have to have a security group on every ENI, basically. So the security group is much more scalable as it is stateful. That means I don't have to do 2 rules per flow. I just have to say what's permitted in, and the response is automatically permitted. Because of that, I typically see them applied inbound, and they will leave outbound as a permit any, which is the default in AWS. I don't know if that's the default in Azure or GCP. If someone knows, please feel free to leave a comment below. So they apply at the NIC level or the VNIC level, or really in AWS speak at the ENI level. And ENI is just a virtual NIC for your instances, the servers and so forth that you're spinning up, the endpoints, right? And every ENI that is created must have a security group attached to it. The security group, you can limit things by protocol, port, source IP, and all security group entries are always permits. Anything that's not explicitly permitted is implicitly denied. I actually have some recommendations for you on security groups. Number one, I recommend you name all your AWS objects, but I think this is particularly true with security groups. Also, you can provide something called a description for security group entries. I recommend you use that as well. The description could be why this rule is in here, something like allow SSH from jump host to network appliance. Or you could put in administrative information like this entry was created based off of change record 12345 on 11/17/23 or something like that. But I would use both of those. It just is going to make your security a lot more straightforward when you have to go through things like audits and documentation. So also another, I didn't put this down here because hopefully this is obvious, but I see it so often, I guess it's not obvious. You could put a permit any into your security group. Please don't do that. I see that way too often. And I think a lot of it happens with, you get an application developer that isn't very network savvy, or a systems person that isn't very network savvy, and they're troubleshooting and they decide, well, I can't figure this out. Let me just put in a permit IP any, and then it works. And then instead of following up, they leave it there and then they can't take it out later, right? So hopefully you got something out of that. I really appreciate your time. Have a great day.
Need help? Call our cybersecurity team and book a consultation with us today.